Hello everyone, this is Justin Hong and today I'm going to talk about Physics 24 project. My topic is how does the nuclear reactor works. So before we start, what is nuclear power? Nuclear power is the use of nuclear reaction to produce electricity. Nuclear power can be obtained from nuclear fission, nuclear decay, and nuclear fusion reactions. The history of nuclear energy. The nuclear energy was theorized in 1939 by Leo and Enrico. Then scientists including Albert Einstein developed atomic bombs using nuclear energy. So in 1942 there was the first man-made fission chain reaction in Chicago by Manhattan Project. There are pros and cons of nuclear power. The pros are it is carbon-free electricity, it requires small land, and it is reliable baseload electricity source. However, there are also cons. First, when we run out of uranium or plutonium, we cannot use nuclear power anymore. And also it is expensive to construct nuclear reactor. Lastly, it is very dangerous. The nuclear waste lasts for decades and the radiation can affect the ecosystem. Nuclear reactor. A nuclear reactor, formerly known as an atomic pile, is a device used to initiate and control a fission nuclear chain reaction, or nuclear fusion reactions. So how does it work? There are 5 features in the operation: fission, heat generation, cooling, reactivity control, electrical power generation. First, fission. When a large fissile atomic nucleus such as uranium-235 or plutonium-239 absorbs a neutron, it may undergo nuclear fission. The heavy nucleus splits into 2 or more lighter nuclei, releasing kinetic energy, gamma radiation, and free neutrons. A portion of these neutrons may be absorbed by other fissile atoms and trigger further fission events, which release more neutrons and so on. This is known as the nuclear chain reaction. Heat generation. The reactor core generates heat in a number of ways. First, the kinetic energy of fission product is converted to thermal energy when this nuclei collides with nearby atoms. Second, the reactor absorbs some of the gamma rays produced during the fission and converts their energy into heat. Third, heat is produced by the radioactive decay of the fission product and materials that have been activated by neutron absorption. This decay heat source will remain for some time even after the reactor is shut down. Then, how effective is this heat generation? A kilogram of uranium-235 converted via a nuclear process releases approximately 3 million times more energy than a kilogram of coal burned conventionally. 3. Cooling. A nuclear reactor coolant, usually water, is circulated past the reactor core to absorb the heat that it generates. The heat is carried away from the reactor and is then used to generate steam. Most reactor systems employ a cooling system that is physically separated from the water that will be boiled to produce pressurized steam for the turbines, like the pressurized water reactor. However, in some reactors, the water for the steam turbine is boiled directly by the reactor core. This is called a boiling water reactor. The picture here is the pressurized water reactor. 4. Reactivity control. The rate of fission reaction with the reactor core can be adjusted by controlling the quantity of neutrons that are able to induce further fission events. Nuclear reactors typically employ several methods of neutron control to adjust the reactor's power output. The fastest method for adjusting level of fission-inducing neutrons in a reactor is via movement of the control rods. Control rods are made of neutron poisons and therefore absorb neutrons. When a control rod is inserted deeper into the reactor, it absorbs more neutrons than the material it displaces. This action results in fewer neutrons available to cause fission and reduces the reactor's power output. 5. Electrical power generation. The energy released in the fission process generates heat, some of which can be converted into usable energy. A common method of harnessing this thermal energy is to use to boil water to produce pressurized steam, which would then drive a steam turbine that turns an alternate and generates electricity. This is the works I used to make this presentation. Thank you for listening.